What's the homework that was stuff like just add these numbers together?
It's possible that we could have numbers multiply themselves. And we try to create that summation. There's also a formula for this. Well, now I gotta remember it. That's not good. Let me not make that mistake. Let me not put it up there wrong. Let's figure out where it's at. Let's look here. There's formulas, and that's really where I need you to look anyway. Write in your notes somewhere that you're going to be on that page for these formulas. Page 288. Great thing is, tomorrow I'll remember it. It's a little bit more complicated. There's a little bit more that it has you do. But this is adding up the first n values, squaring them first, and then adding them together. So you have 1 squared plus 2 squared plus 3 squared plus 4 squared, and so on to get added up. But we're going to use the formula primarily. They give you two others on this page. One of them is the summation I equal 1 to n of some constant number. So in other words, 5 plus 5 plus 5 plus 5 plus 5 n times. So how do they tell you we evaluate that one? C times n or n times c, whichever way you want to write it. Basically, if you're adding up a number to itself so many times, you just take that number times the number of times you add it up.
Are they using C as okay?
Is that the same symbols they use in there?
Yeah.
Okay. The last one that we're going to look at, this does not mean that this is the last one of these formulas. It's just the last one we're going to look at in here, is I cubed. From I equals 1 to n. Let's see, is this n squared times n plus 1 squared over 4? Remember that right?
Yeah. Yeah.
Okay. Now we can build and develop other forms, but in here we won't need those other forms at all.
Okay.
Questions so far? Yes, ma'am. This is like some number. So, for example, maybe I want to sum up I equal 1 to 15 of 7. So what does that mean I'm going to do? That'll be how I get the final result. What it really means is 7 plus 7 plus 7 plus 15 of those 7s. So we're going to say, yeah, I know multiplication, so it's 7 times 15. And that would give me my result. Questions?
What if the I on that was like 3?
Oh, that is an interesting question. Everybody got these copied?
Mm-hmm.
Okay, so let's look at a situation like that. Let's just do that. Our formula does not let us start at 3. We start at what number? 1. So let me ask this question. Is this the same as this? Sure. Wait a minute. What do we think? Let's talk about it.
Yeah. Yeah.
What does this right here do?
Means they're going to go by 1.
Means we start at 1, so we're taking 1 and 2, and then 3, 4, 5, all the way up through 85, right?
Then we're subtracting out 1.
But then this is saying let's get rid of the 1 and the 2. So we actually started at 3. Does that make sense?
Mm-hmm.
Now, I think It might be obvious to you that instead of writing that mess, I might just write -1, -2. Okay? But if I didn't start at 3, maybe I started at 70 and went to 1,000, you kind of want to be able to say, is there a way I can do this starting from 1 and going out to 1,000? And then subtracting off the 1 through 69 stuff. Does that make sense? That was a great question over there.
Is that something we're going to come across?
You might come across that.
We're going to come across this? So right.
Yeah, you might want to write this down. But this is how we kind of deal with a different starting number than 1.
Can you explain that again?
Can you,
Alright, copy.
can you start with a number with like start at 100 and go to 1,000? Start that
Yeah,
way?
what would
Sure.
that look like?
Okay, I think it's pretty clear to all of us that we really don't want to type all these numbers in some kind of calculating device by hand. We want to do something else to it. The formulas that we have always start at 1 and go out. So if I start at 1 and go out, I've introduced a portion of numbers here that are not here. In fact, 1 through 99 times 3 added up. So what I need to do is I need to be able to subtract away the part that I introduced. And so this gives me a sum from 1 to 1,000 of this time. But this then takes away the part of the sum from 1 to 99. Should that make sense to leave me with 100 to 1,000?
Why'd you put that 3i instead of just an I?
Well, we might just not just have I. We might have a number times the I. So I want you to...
Plus I.
Yeah, that could happen too. I mean, we can do all kinds of things.
So which...
So we do have an equation right there before we even do the problem.
Mhm.
That'll be the start of it to get rid of the 99 and then go to the 1 and do the 1.
Yeah, and this way we get to plug into our formulas. That's the whole point behind this.
So then
And
to
then
like,
plugging into the formula, you would still get the right answer, right?
Yeah.
Because you're taking it away.
Which formula do you use for the 3i?
Could, well, I shouldn't say could. This is a property we need to understand. It's 3 times
Okay.
that sum.
So just multiply.
So it's just going to multiply by 3. Same thing here and here.
so you don't have to do the in plus. Okay.
No, that's it. This one.
No, you would do that, but I would actually do it this way. 3 times 1,000 times
Did you get
1,001 all over 2 minus 3 times
Oh, okay.
99 times 100 all over 2. That should be this sum. It makes sense. Okay.